Welcome everybody. We are going to take a little bit of time here to learn a little bit once more about parametric equations. And we'll see if we can go to review here, get the pen up, start inking. That's going to allow us to ink over here. And you'll notice here that a format that you're going to see over the next year. And that's trying to put a lot on the page, but I'm kind of showing you a little bit here about math. You're going to see here where I can write some equations, and I'll just write one here. How about x equals 5t? And I'm going to write here y equals 6t. Put these together are something we call parametric equations. So in other words, both x, y, and you could do actually z, we'll try that in a little bit, are all functions of time. And this is something that is going to be very common in a lot of engineering, particularly in something that has to do with the weather. All right, so this is a parametric equation, and we have on the right here, of course, your tried and true. I'm clicking between the two, your tried and true Excel, where you can do a lot of parametric equations. And what I don't have up that we very often will be a calculator. The setting, just remember, the same place you set your settings for radians and degrees, you set them for parametric. And down here, of course, we have our old friend Wolfram Alpha. And we'll learn to do all these things, and notice how Wolfram sends us into Mathematica, which does parametric equations as well. The classic thing to do with parametric equations is usually, if you look at something here, and we're going to go ahead to remember, of course, to learn to set our coordinates, and I'm going to do a much better job this semester to set our coordinate systems of x and t here. I'm sorry, x and z, which means that y is going to be into the board, is going to be y, right? If you want to remind yourself of that, you take your fingers in the direction of z, turn them towards x, the way your thumb points is y. And so right now, what we have here is going to be a constant z, so that's going to be something that's moving around in this plane. We could add this, z equals 1t, and now we have a three-dimensional parametric equation with respect to time. Let's remember also that if we write things up in standard format in mathematics, we're getting used to, for too long, x, y, and z looking like that. In all reality, we write it up as a vector, x, y, and z. So you'll see that this form of equation is probably the single best way to deal with the kinematic equation. And you do things by kind of getting rid of t here by substituting in one thing for the other. Over here we can do the same process for this graph, and down here we can do, and we'll try that one right away, graph x equals 5t and y equals 6t and z equals 1t. And let's see what if it interprets that, and if it does it with 3D like it should. Now, what you'll notice, the great thing about parametric equations is it not only gives you the shape of the thing, it gives you where the thing is at any one particular point. So let's see how that does it. Okay, it didn't like this in 3D. So we're going to go back here. We're going to just do it this way. Let's do those two. And once again, Mathematica would have dealt with the third dimension a little bit better than Wolfram. $40 for a student to get Mathematica. And you see then a representation of the graph. Alright, so that's parametric equations. So what are the inputs? Well, very often what we're going to review here is the fact that, remember, we want to build our spreadsheets as durable as possible. So let's just basically put in, really our only input here is t at some point. What is the t is going to be the parameter, and so if I basically have t there, here we could actually have a table of x and a table of y. And quite often I think you were getting pretty good at right-clicking, probably going to format the cells, maybe coloring them up with a little fill that you can kind of color in. You know, just for highlight right there, right-click, format cells, something there. Remember, X is usually red, Y is green, and Z is blue. So let me make the Y green to tie it later on to your CAD colors. X is red. And T is just T. Well, what in fact is the formula for X and Y? Well, I'm going to put T up here. That's good. T is there. Get rid of that. T doesn't have the color, and we can talk about making something called a delta time step. In other words, we're going to go from T1, 2, 3, 4, 5, 6 if our time step is 0 or is 1, but we might want to make the time step smaller. And when I talk about making durable spreadsheets, you want to remember, oh, if it's something I'm going to be changing, I might want to make that as an input as well. So I'm going to go here, go right click, insert, and over here I'm going to put delta T. And delta T is just going to be a 1 input here. And so this delta T is there, and then delta T. And we might want to also add not only a delta T, we might want to add a time initial. Insert entire column, time initial. Learn to completely build more and more and more your spreadsheets so it is something that is durable. So let's start here. Time initial. We'll make our time initial for now 0. Our delta time 1 typically at the very start. And we can start with our time. Well, our first time, we should remember the equal sign. It should be equal to that plus that. And that would be great, except for that's only going to work in this one cell here. What I would like to do is to tell it that I would like this to be at the start, the absolute location of that, plus the absolute location of that. Now, that's just for your starting one. What you're going to now want on the next one, of course, is going to be the location of the one above it plus the location here, and you want to have, in fact, build this durable spreadsheet so it's going to the right spot. And you'll see as you go ahead here and pull these down, I like to use right-click copy all the way down to paste. And you have these values. But what that lets me is if I want to change my delta T to 0.1, it all works well. If I want to change my time initial to 6, it all works well. So that idea of making a spreadsheet durable. If you notice here, my time initial went to 0. Everything's lined up. And now what is the formula for X? Well, X is equal to, well, basically, in this case, we said 6, but there's another thing we could have put in as a parameter. We could have called it A and filled it in, but I'll just go ahead and do 6 times that value. I'm going to go back here, equals 6 times that. Doesn't like that. Equals 6 star that. Equals 6 for the Y, I had the last one wrong, star, which is time, this one over here, and of course this one was 5. That's all well and good, but what are we missing? We're missing a column above it, or one line above it. So we're going to go here at time initial. Time is not the time. The initial time at time 1, it's 0.1, so I don't have the 0 point here, which is a 0, 0. And I won't do that right now. I'm going to grab this here. Remember, you can right-click, copy, go down here, right-click, paste, right-click, copy, go down here, all kinds of different things, and paste. Or, didn't do a good job there, or I can pull it down. And I think when you go to Google Docs, the pull down is going to be more consistent. And so you have a time 1 here. And what do you have then? You have, at least in this spreadsheet, something here where your time initial, your time delta, but basically you might want to do this now. Get the spreadsheet built and make it a little bit more durable. And might put in X coefficient and Y coefficient as entry points. X coefficient in this case we knew that was 5 and Y coefficient was 6. And now you go back to this original equation here. Instead of it being times C2, it's going to be times this, and it's got to be absolute to the dollar signs. Absolute the dollar signs. That changes that just one there. Right click, copy, right click, paste. Not quite right. If we look at it's A5 times, did something wrong there. We really grabbed the wrong one. We wanted this to be equals that with the dollar signs and the dollar signs. And we want that to be times, and I'm looking for the 15 minutes here coming up on it. We should be okay. Times the time there. That's correct. Grab that, pull it down and paste it so that looks like it's working. Same thing here. We want that to be equals to this coefficient. Again, the absolute location, the dollar sign, single most important thing. Star, in this case to the left, it's a relative position. Take that and pull it over. Take this, right click, copy, right click, paste, and you have that, and you have something that's much more durable. Eventually the type of thing you like to do, I think you've done hopefully, is to take all of this and protect it. I'm not going to do that right now, and maybe colorize it, but here are your inputs. Basically you might want to put these in some color that tells you that it's an input. We're going to go down to format cells. Maybe we're going to make our input colors something that we know. Purple has got to be input, and we've got to input here. Right click, format cells. We'll make purple our input perhaps, and now we know that these are the numbers that need to be input. So as I go ahead and I can change that, it should change my spreadsheet. I want to change the coefficient there, the slope along the x. I want to change the coefficient slope along the y, and then eventually you can see you can graph that. And of course what then becomes pretty easy in a spreadsheet is to make that z and get some 3D information that will pass, whether it's a storm, whether it's anything else. So remember the term parametric equations. Very often they work in threes when you're doing in 3 dimensions. Remember to, when you label up your axes, to use the, make sure that we start using the Z on the board so we get used to that. Later on we'll be able to do transformations and move them around and get used to starting to use Mathematica. And why? How do we get Mathematica if we don't own it? We use Wolfram Alpha, and we look for some of the forms that you'll see when it says Mathematica form and whatever else. Thanks for listening.